This is James Ball of the Hacking Beavers group. There are a small number of topics I want to cover for week 7. First is an overview of the progress our team has made in hacking new features of the game. Second is the work I've done personally in building the initial GUI. Third and finally is the injection hack we're learning right now and why we want to use it. When we last left off, we were able to use read and write process memory functions to alter the player's supply of mana. Mana was an easy variable to find because Cheat Engine allowed us to backtrack through the pointers until we reached a static address. Now that we've had a bit more time with the game, our group is able to alter the player's health, speed, jump height, fire damage, and more. There are a few ways to find these values in the game architecture. One is just by looking. After mapping jump height and walk speed, which are adjacent in the player structure, I noticed that we were getting a lot of integers and floats in this area of memory. This value here will always seem to reflect the slot that was highlighted in the player's quick access bar. Another is by educated guessing. Xiao noticed that the dynamic address for health was always the same distance from the dynamic address for mana, so by changing the final offset, he found a series of offsets that always pointed to health. Yet another method was by better understanding our toolset. Brock was able to navigate the list of functions in Cheat Engine to find a series of offsets that allowed us to find the applied damage of the Fireball spell. We had decided early on in the project that we wanted a menu, or at least some kind of visual aid in our trainer so that the player knew what options were available at a glance. I spent a great deal of time looking at the different tools that would allow us to build a GUI. At first I tried WX Widgets because I'm a sucker for open source, but making all the tools play nicely with Visual Studio proved to be more trouble than it was worth. I settled on Qt, or Qt, which provides a relatively easy environment to set up your graphics, and wasn't too difficult to integrate into an existing Visual Studio project. The toolset is a bit finicky, and I found myself relying on built-in functions like onButtonPressed. This required refactoring our team's existing code so that each individual hack fit neatly into their button function rather than one while loop. Qt allows drag and drop to place things like checkboxes, slider bars, buttons, and labels to a window. On the right, we give these items names so we can access them from within the code. When the initial Start Trial button is pressed, we go ahead and look for the target process ID and load the key offsets. Each of these buttons toggle the cheats for mana, jump, speed, etc. Turning them on will overwrite the address with the new variable, and turning them off loads the default values. Exit simply triggers a flag that quits the entire application. We change these labels on the right from on and off by using the command UI jump label set text. There's also the option to display pop-up windows to the user. Notice that if we try to start our trainer without an actual game present, then we get an error, cannot find target process. The same thing occurs if we try to activate a cheat without attaching the trainer to the game. Overall, I'm pleased with the end result, as anyone familiar with a video game should be able to navigate the menu. The biggest change I'd like to make is to integrate it as an in-game overlay instead of requiring alt-tabbing, which brings me to the final topic of the video. We want to take our hack internal. What this means is that instead of relying on reading and writing to process memory by opening an existing process, we want to inject a dynamic linked library into the game's process. Why? First off, it's good practice, both in the sense of we need the practice, and from a penetration perspective, an internal hack is generally harder for a system to detect. We also found some great examples of in-game overlays in existing games we're familiar with, and they use DLL injection. So while I'm not an expert, I understand the value of emulating experts. In addition to getting an injection working, I also want to address the changes I made to the health and mana cheats. You'll notice the pools aren't replenishing at the bottom of the screen as mana was in the earlier video. This is because after implementing Qt, I wasn't able to use the onPress button functions while also traversing the while loop that constantly refreshed the values. One option to fix this is multithreading. I was able to implement OpenMP multithreading on a copy of our original repo so that health and mana looped on one thread while the other cheats ran on a second. My hope is that one thread can run a loop while a second checks for user input, and each thread shares flags that indicate whether a cheat is on or off. This is still in the debugging process. My hope is that once we are able to inject our DLL into the game, we can simply rewrite the assembly via a hook and prevent health or mana loss altogether.